The Chemistry of Aquariums on Fish by Andrew Alcock and Miles Reeker. The most popular pet in America is freshwater fish. Most people who own these fish, however, do not know the advanced ways to care for their aquatic friends. The first thing to know is that a tank with a filter is the best way to get constant dissolved oxygen flowing to the fish's gills. pH ranges. When setting up the tank, the water needs to be perfect for the fish to thrive in their environment. The pH of a freshwater aquarium can range from anywhere 5.5 to 7.5, depending on the species of fish. In our case, goldfish and guppies, we have the goldfish need around 7.1 to 7.5. The guppies need around 7 to 8.5. A more neutral pH means that harmful chemicals and acids have been removed from the water, creating a safe aquarium. This is a chart to see the full more species pH ranges. As you can see, here are the mollies and guppies pH range, as with more common freshwater home fish. Water treatment. Ammonia and chlorine are the most harmful chemicals found in fish tank water. Ammonia spikes happen in an aquarium when fish or other organisms release ammonia as stressed out waste. In a new tank, ammonia will continue to build and be harmful to the fish's gills. In an already established tank, the beneficial bacteria in the tank will attack the ammonia, just like the T cells and B cells of a human immune system. Ammonia can be neutralized using ammonia neutralizer, which has sodium hydroxymethane sulfonate, or rongalite, to combat the ammonia. Chlorine is another harmful chemical commonly found in most aquariums where it shouldn't be. Chlorine comes from tap water, which is what we used and what most people use to fill their tanks. Excuse me for laughing, Parker just threw a paper towel at my head. In order to make tap water breathable to fish, you must use dechlorinator, which has the main ingredient of sodium thiosulfate, eliminating all chlorine and dangerous metals in the tap water. Water filtration. Now this is Andrew's part.
Greetings, one and all. Water filtration is necessary because the uneaten food and fish waste in the aquarium creates ammonia, and in turn nitrites, which are toxic if not turned into nitrates. Although not directly toxic, nitrates should be removed because it can indirectly cause health problems and it contributes to algae growth. There are three main types of filtration: chemical filtration, biological filtration, and mechanical filtration. There are many different types of chemical filtration, one of them being activated carbon. Activated carbon is a highly porous form of graphite and has a very large surface area of up to 1,500 m². Works through a phenomenon called adsorption, or the containing of aqueous and gaseous molecules in the internal or external surface of a solid. It comes in tablets that dissolve in water and absorb the harmful chemicals. Another type of chemical filtration is zeolite. Zeolite, also known as clinoptilolite, is another chemical filter. It has a formula that can work with different elements shown here. It is very complex, and it works with sodium, potassium, or calcium, and also aluminum or silicon. Its structure is complex, but also mainly tetrahedral. You can see this GIF on the left. It captures and eliminates toxins and can balance pH. It is one of the only negatively charged minerals with CEC, or cation exchange capacity, or the number of cations a dry soil is capable of holding. The third and final type that I will be covering is resin. Ion exchange resin comes in small beads that act as a media for ion exchange. It's used in water softening and water purification as an alternative to zeolites. It uses cation exchange to remove hardness in water, and immediately after comes the anion exchange, which purifies the water. If you look at the picture on the right, you can see that the resin beads come in with sodium, and the ion exchange takes place and it removes calcium and magnesium. This is a picture of water softening on the right. Water softening is the replacement of magnesium and calcium ions with sodium ions, and water purification is the removal of poisonous and heavy metal ions and then the addition of sodium or potassium. By poisonous and heavy metal ions, an example of poisonous would be copper, and an example of a heavy metal ion would be lead. Biological filtration. Biological filters are the most common filter, and they typically require less maintenance. It works through a process known as cycling. Cycling is the establishing of a bacteria bed in the filter, and this bacteria digests ammonia and turns it into nitrite. The filter produces bacteria capable of digesting nitrite and turning it into nitrate. Nitrate, as I said, was not immediately harmful, but it can contribute to the loss of appetite for the fish. The removal of nitrates, which you need to do every so often, happens through a process called water cycling, where you remove around 10 to 15% of the water in the tank, and you replace it with dechlorinated water. Mechanical filtration or filter pads. Mechanical filtration, known as physical filtration, is the pushing of water through a media or some kind of strainer. These medias do have to be replaced, and they come in different varieties. The free-flowing particles throughout the tank are caught in the media, so a finer media is recommended, but they do require replacement more often. Filter pads are the media that is necessary for the mechanical filter to work. Usually manufactured from cellulose, diatomaceous earth, which is siliceous sedimentary rock, low density because of high porosity. When you think of high porosity, you think back to the carbon, and perlite, volcanic glass with high water content formed by the hydration of obsidian, and synthetic fibers with resins attached. Aeration, or oxygen in aquariums. Aeration is the adding of oxygen into the ecosystem. It occurs naturally on the water surface in aquariums, but for the fish to survive, they need a little induced help. So most tanks do this naturally. They, like most ecosystems, they get oxygen in naturally, but in fish tanks, the fish can't survive unless we help them. Most filters circulate water provide oxygen to the tank because of the churning on the surface. Circulation is vital because it moves water to the bottom of the tank to remove carbon dioxide from the system and add oxygen. Bubblers, as cool as they look, are often vital to the well-being of the fish. This diagram to the right shows what I mean by aeration. This is how oxygen enters the tank, and then carbon dioxide leaves. And this is a bubbler. Freshwater and saltwater tanks.
Saltwater tanks are much harder to maintain, as you always have to keep an eye on salinity to make sure that the fish can stay alive. The pH range for a saltwater aquarium is about 7.6 to 8.4. This higher pH is because the salt adds a bit of acidity with NaCl. In another sense, the concentration of hydrogen in the water, pH, is alike to the freshwater aquariums, except that it has NaCl and not pure water.
So freshwater tanks, as Miles said, the saltwater tank, saltwater fish thrive around water pH of around 8 or so. Freshwater fish thrive on a slightly lower pH range of around 5.5 to 7.5. Freshwater also circulates more easily than saltwater does because it doesn't have the NaCl. It doesn't have almost NaCl in it, and saltwater is really dense. So freshwater, because it's a lot less dense, it circulates water much more easily.
When setting up a fish tank, you want to make sure all the gravel and plants that you put into the tank are washed off thoroughly with warm water so that no dust particles can be in the water when the fish are put into the aquarium. When initially filling up the tank, tap water is okay to use. This will later be dechlorinated using tap water conditioner that will make the water safe for the fish. Once your aquarium is full, then it's time to add the tap water conditioner. This will remove all chlorine effectively from the tank water. After at least 24 hours, it's time to add your fish. The water has been thoroughly cycled, where you have enough beneficial bacteria and no chlorine remaining in the water from the tap dechlorinator. Now it's time to add your fish and enjoy.
Yeah, I'm gonna take my horse
Fish breathe oxygen in the water that is soluble. This oxygen is made soluble by water flow, which can be created by all filters to make the fish's life happy and make sure that they get enough oxygen flowing to their gills so that they do not die.
These are our sources.
Thank you for watching.
Stay thirsty, my friends.